Hello, let's continue our Sudoku adventure with Dodgeball by Randall. So we're going to be dodging some balls here. Let's go over the rules. We have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have Kropke dots in the grid. White dots separate consecutive digits. So if this was a 2, this could be a 1 or a 3 in order for these digits to be consecutive. Black dots separate digits that have a 1 to 2 ratio, meaning one of them is exactly double the other. So if this was a 2, this could be 1 because 2 is double 1, or this could be 4 because 4 is double 2. The order doesn't matter. What matters is that one of them is double the other. Not all of them are given. So if this was 2, 4, there could have been a black dot there. There's not. That's perfectly fine. We're allowed to put the 2, 4 next to each other. We're also going to be drawing a loop. So we're drawing a single consecutive loop through the grid. Consecutive loop. Maybe it means orthogonal loop. Or consecutive meaning that it's a single loop. Yeah, I think consecutive is being used here a little bit strangely, but I think it just means that it's going through the grid, like this. It's attached to itself, right? It's a loop. It's what you'd expect a loop to look like. It doesn't touch itself. So for example, if these cells were part of the loop, I couldn't turn right here, because if I turned right here, it becomes ambiguous which way the loop was going. So I'd have to go up here and around, right? Because I'm not allowed to touch myself orthogonally. I can touch myself diagonally though. So if I do that, that's perfectly fine because the loop doesn't go diagonally, so that's not ambiguous. And I'm going to be shading cells green to designate the loop here. We could use the pen tool to draw the loop, but I find that when you have that non-orthogonal rule, it's actually a lot harder to see that you've accidentally done that. It does touch itself orthogonally here, but it doesn't become ambiguous the same way that shading it does. So I'm going to use shading for that instead. So what are the rules of our loop besides that we're drawing one? It doesn't touch itself orthogonally, and it doesn't pass through any circles. So we can't do this with our loop because that passes through a circle. So none of the circle cells are loop. Additionally, each digit in a circle. Sorry, let's not skip a rule. The loop must pass through each 2x3 box exactly once. What does that mean? That means we're not re-entering. The loop can't do that because it visits this box once, then it leaves it, and then it visits it again. Not allowed to do that. But it does pass through every box once. So if we can't do this loop because it doesn't touch these boxes. It doesn't touch these two top boxes. Okay, so additionally, the circles, whatever digit we fill in the circle, say this was a 3, that tells you how many cells the loop occupies. So in this case, we could do ignoring the circle rule, we could do this because 3 of the cells in the box ended up loop cells. That's another reason I'm going to use shading on this. All right, so those are the rules. I believe in you. You can do this. These puzzles are designed to be entry level for any constraints we use, especially interesting ones like this. So I do believe you can do this. It is still an adventure level puzzle and intended to be an intro to these constraints. So definitely give it a try yourself. There's a link in the description, and I'm going to get started right now. All right, the first thing that I see is that all of these cells in this box except one are touching a black dot. So what does that mean? Well, a black dot can't have a 5 on it. If I try to put a 5 on a black dot, I can't double it to 10, and I can't have it to 2.5. So 5 just cannot go on a black dot. It doesn't have a buddy. So where does 5 go in this box? Well, none of these cells, so it has to go here. Now that this circle is a 5, it's telling us that, first of all, actually, I want to color every circle gray to designate that it is not part of the loop. But what we've learned that all of these are part of the loop. All of these cells are part of the loop. And the reason we know that is because we need 5 cells to be in the loop because of the 5 in the circle. Now, this one has to keep going, right? The loop can't end. It has to go all the way around. So that's going to go down here. And now that this has entered this box, this loop has to, remember the loop is like this, right? So actually this cell can never be entered because it would be touching itself orthogonally because we already continued to here, and it can't continue down. Because if it continued down, then it would re-enter this box. So it has to go right. And then that means that this cell's never entered, because if we tried to do it this way, we'd be touching ourselves orthogonally. So this continues here, but then it can't go right, so it goes down. And now this is either going to continue down straight here, or it's going to go right and then down. So this is in 3 or 4 cells. We can fill the 3, 4 here. There's more digits we can do up here, but let's continue the loop as far as we can. This loop has to continue here. It has no choice. It has to continue. We're never going up in this corner. We're also never going in this corner while I'm at it, because we get stuck. We couldn't leave. So this is either going to be in 2 or 3 cells. And this is where I think the digits I was talking about come in. So let's think about these black dots, specifically this one. This is a chain of 2 black dots where the digits can't repeat because they're all in the same box. So what's this middle cell? Well, it has to be a digit that can go with 2 other digits. And in a 6x6, that's only 2. 2 is the only digit that can be surrounded by 1, 4, right? Otherwise, 3 would have to be double 6, 1 would have to be double 2, 4 would have to be double 2. So this is how that resolves. That makes this a 3, which means this has to be the third one, and then it has to loop down. And it can't go left because if it did, it would touch itself. So it continues to go down. Now it has to go left. And now it has a choice. It can either continue left and go down, or it can go down immediately, which means that this is 3 or 4. 3 would go with 6, 4 would go with 2. Okay. This can't exceed 4. This is 1, 2, 3, 4, I guess, for what it's worth. All right, that feels like progress. Oh, we know this one's 3, 6. I didn't follow up on that. We can place the 6 and the 3. That makes this a 4, so this has to take this cell. Now, if we continued here, we'd finish the loop, and these wouldn't have anything in them. that would break. So we're never entering this cell because it would finish the loop, which means this goes down and this goes down. Now that this has gone down, we can't enter this cell. It would touch itself, which means we're not entering any of these cells. So it goes immediately right. That makes this a 1. That's a 4 and a 1. Okay, and our loop's done. That finishes our loop. These are not loop. So this is a 2. 2 can go with 1 or 4. And this is a 3. 3 goes with 6. All right, so all of our circles are filled. We still have these white dots. Okay, so here's a trick for white dots that's always useful. You can think about this in a bunch of ways, but I like the even odd trick as just sort of a quick mental thing, which is every white dot, because the digits are consecutive, one of them will be even and one of them will be odd. Because if you think about it, 2 consecutive digits, if one of them's not even, the other is. So there's only 1 even digit left to go on this white dot, which is the 6. So it needs a 6 on it, and this one's not the 6. The 6 goes there, and 6 goes with 5 only. And so then this is a 3. 1 in this box goes here. This one looked down. This is from, we need the 3 and the 2. These are 2 and 5. That's 5, that's 2. These are 4 and 6. We don't know the order yet. Oh, but yeah, okay, sorry. I thought the 2 resolved it, but it doesn't. This is resolved, though. This is a 4. And so this is 1, 2, 5. Let's fill that. Up here, we need a 4 and a 5. This 4 tells us the order. That gives us the 1 here. And then down here, we need 1, 2, 6. This can't be 1 or 2, so that's 6. Okay. This is known. That should help. This is a 3. 3 can go with 3 DT do it in the corner. 3 can't go with 2 because 2's in the box already, so it goes with 4. And that resolves basically everything. That's a 1, 2 and 1, 5 and 2. It resolved everything. 5 and 6 are left, and there we go. Cool puzzle, Randall. I enjoyed that. I think it was a good choice to do highlighting instead of the pen tool, because I think with the pen tool, it's a lot harder to see the non-orthogonal touching rule. And also harder to count how many cells are green versus gray. So yeah, definitely for this kind of loop where it doesn't touch itself, the no touchy rule came out of the fact that we haven't always had the pen tool. I know we've had the pen tool for years now, but the rule has kind of stuck because it would be ambiguous if you tried to highlight cells to make the loop. But anyway, a little history lesson for you. I enjoyed this, Randall. Thank you. Some cool logic there. Let me know how you did on this. And of course, if you enjoyed it, then why not leave a like, subscribe, and a kind comment below.